Stats number three. So this is lesson number three in stats, and we're going to take a look at a little thing called Z-scores. Now, when we're talking about stats, usually what we're trying to do is we are comparing different groups of data or different pieces of data. And really, when it's all said and done, that comes down to, where do we fit on a scale? Okay, where do we fit on a scale? Are we really high on a scale? Are we really low on a scale? We use stats in all sorts of different areas. We're going to take a look at an example and see how two things might be able to be considered fair or unfair. So let's take a look at the first one here. Let's take a look at this first example here. Let's imagine, or let's say that you are preparing to go to school and you have gotten a 70% in my grade 12 math class. Okay. Now your cousin is in Mr. Danger's class and he goes to Springfield Collegiate and he also got 70% in that class. Are these two marks equal? If you both get 70% in a class, is that actually equal? Have one of you done better? Should a university accept one of you or the other? Should one of you get a scholarship and not the other? If there's only room for one, who should get the call? Okay. Now, if we take a look just at the mark, 70% is the same as 70%. Done. Okay. There's really nothing to take a look at that. But as you all know, being in a different class could make a difference on your mark. Okay. Your 70% might actually be better than somebody else's 70% based on the teacher that you have. Some teachers mark a lot more difficult than others. Some give extra bonus marks. Okay? All of those things come into play. So if let's say, and this is what I kind of put in here, if let's say Mr. Danger marks really easy, he gives lots of bonus marks, you spell your name correctly, boom, extra bonus mark. Well, like that could make a big difference on your scores. That 70% could be very inflated. Okay? The most acceptable method would be to use each student's Z-score. Now, a Z-score will show how well a student did with respect to others in the same class. Okay, so I'm just going to kind of put that in there. I'm just going to highlight that with respect to others in the same class. A Z-score compares you to others in a class or in a group. Okay, a Z-score compares you to others in a group. If you talk, we'll get into this a little bit later, but if we talk about how, let's say, your height or weight compares to others, and we do this with babies all the time or young kids all the time to see how they grow, not so much with teens and adults. We don't necessarily want to be compared a whole lot, but if we compare, we'll be told kind of where we stand according to a normal. A Z-score does that, and Z-scores are what balances you according to a normal. Now, a Z-score of 0 is going to represent average results. So if you are right at the average of your class, you get a Z-score of 0. Okay, so a 0 is average. Now we have to kind of change our minds a little bit to think that way, but if we get a Z-score of 0, that's average, that's right in the middle. A negative Z-score means that you are below average, and a positive Z-score means that you are above average. Okay, so a Z-score is going to be just a number. There's no units to it, and it's going to represent where do you stand according to average. Okay, where do you stand according to normal? Now, specifically, the Z-score measures how many standard deviations you are from a mean. Okay, so this is where we take our standard deviation, and we're going to use it to balance where you stand according to a mean. So if we give an example here, if let's say the class mean is 70% and there's a standard deviation of 5%, this chart shows us what our Z-scores are. So if we go one standard deviation down, we're at a -1. Two standard deviations down, -2. Three standard deviations down, -3. So this represents that standard deviation that we took a look at. Okay, where do we fit on the standard deviation mark? Okay, same way going up. If we go 5% up, that is one standard deviation. Two standard deviations, so 10% up would be 2, and three standard deviations would be 3. Okay, so now this kind of represents where we stand. So let's again say that you get 70%, you have a Z-score of 0, meaning that you're at average. If you're at 80%, you got a Z-score of 2, meaning that you are above average. 60% would be a -2, you're below average. That's how we represent it using a Z-score, okay? Now, not all of them are going to be this neat and tidy, so we have a nice little formula that we can use for Z-scores. A Z-score is going to be represented by the letter Z. Okay, so it's going to be represented by the letter Z, and how we're going to find that is we're going to take X, our data point, and subtract the mean. X minus the mean, okay, X minus X bar, and then we're going to divide that by the standard deviation. And this is going to tell us how many standard deviations are you away from the mean. So it's going to represent the number of standard deviations you are away from the mean. So if you are at 75, it'll be 75 minus 70 divided by 5, which will give us 1. Okay, and that represents your 1 standard deviation above the mean. Okay, so it represents. We're going to talk a little later in a separate lesson about what that represents with percentage-wise, so how many people are above and below you. Talk about that later. But right now, we're just going to look at the Z-score and how do we solve for Z-score. So formula for Z-score right here. That will not work. Okay, formula for Z-score, the data point minus the mean divided by the standard deviation. Okay, data point minus the mean divided by the standard deviation.